Solving quadratic equations by factoring. There are 7 topics we want to discuss in this lesson. First, vocabulary. Second, using factoring to solve quadratic equations in one variable. Third, find the x-intercepts of a graph or polynomial function. Fourth, know the connection between the x-intercepts of a function and the equation. 5, use factoring to solve cubic equations. 6, use graphing to solve polynomial equations in one variable. And lastly, compare solving polynomial equations with factoring polynomials. Please take a moment, pause the video, and jot down the vocabulary. Alright, a quadratic equation is an equation, a quadratic equation in one variable is an equation in the form ax squared plus bx plus c. That just means, a quadratic means I have a second degree polynomial. The zero factor property says when I multiply two numbers together and get 0, one of those factors has to equal 0. A cubic equation in one variable is a polynomial that is a third degree polynomial. So, using the factors to solve quadratic equations in one variable. If I have this equation and it's set equal to 0, that means one of these two factors must equal 0. Either x minus 5 equals 0 or x plus 2 equals 0. So when I solve for x in both of these equations, I end up with x equals 5 and x equals negative 2. If I have an equation and it's not in factored form, then the first thing I must do is put it in factored form. And we'll do that by product sum. And so what would you multiply together to get negative 8, add together to get negative 2? That would be negative 4 and positive 2. So w minus 4 and w plus 2. I set these equal to 0. W equals 4 and w equals negative 2. For x-intercepts, we do the exact same thing. It's important to note that for an x-intercept, the y, which is f of x, must equal 0. And then we do product sum. And what would you multiply together to get 10? Add together to get negative 7? Negative 5 and negative 2. So x equals 5 and x equals 2. And then this part is very important. If we ask for the x-intercepts, that means that they are points, and we must write them like points. An x-intercept is the point where the line crosses the x-axis, and it crosses at the point 5, 0 and the point 2, 0. Alright, there are 3 types of solutions we can have. You can have a situation where you have 2 x-intercepts. You can have a situation where you have 1 x-intercept. A situation where you have no x-intercepts. That's for any quadratic that we graph. You will either have 2 solutions or x-intercepts, 1 solution or 1 x-intercept, or no solution, which means it does not cross the x-axis at all. An example of those would be if x were to equal 3 and 5, or if x were to equal 4, that's just 1 solution, or x equals nothing. You cannot find a value for x, which means there's no solution. So please take a moment to pause the video and try to solve for x. Okay, so product sum, we would end up with multiplying. What could you multiply to get 25? Same 2 numbers add together to get negative 10. negative 5 and negative 5, so x minus 5, x minus 5. There's no need to set both of these equal to 0 because x is just going to equal 5. So don't put x equals 5 and 5. X equals 5 will be good enough. In this problem, the first thing you want to do is factor out a monomial. So I can factor a 2 from each term. When I divide out a 2 from each one of my terms, I now have a quadratic here, and I want to factor this using product sum. Well, notice the leading coefficient is not 1. Because it's not 1, my product will be 2x squared times 15, and my sum 13x. And then what would you multiply together to get 30x squared, add together to get 13x? We substitute 3x plus 10x in for 13x. Since I have 4 terms, I want to factor by grouping. And remember, my factors are, now in this situation, I need to set each one of these equal to 0. And then I solve for the first equation and solve for the second equation. So x will equal negative 5, and x will equal negative 3/2. In this situation, the first thing we want to do is set this equation equal to 0. Then we want to go through and do the product sum like we've done before. So I set this equal to 0 by subtracting 5x from both sides and adding 20 to both sides, which now gave me 0 on this side and gave me this quadratic on the left-hand side. So what could I multiply together to get 40x squared? Same two numbers add together to get negative 13x. So I'm going to substitute negative 5x plus negative 8x in for negative 13x. Since I have 4 terms, I'm going to factor by grouping. In my first set of parentheses, I'm going to factor out a 2x. In my second set of parentheses, I'm going to factor out a negative 5. Remember, you never want the leading coefficient in this group of parentheses to be negative. So my factors, one factor will be the stuff inside the parentheses, x minus 4. The other factor will be the stuff left outside the parentheses, 2x minus 5. I set each one of these factors equal to 0 and solve accordingly. So x should equal 5/2 and x equals 4. In this problem, we are not equal to 0, but we must be equal to 0. Remember, in order to find a solution means an x-intercept. An x-intercept means the y value is 0. So the first thing I must do in this problem is I must FOIL in order to turn this into a quadratic. Then subtract my 7 from both sides. And now my quadratic is set equal to 0. I can now find the x-intercepts, also known as the solutions. I'm going to do this by product sum. So what can I multiply together to get negative 15? Add together to get negative 2? Negative 3 and positive 5. So my solution, x minus 5 equals 0, and x plus 3 equals 0. So x equals 5, and x equals negative 3. In this situation, I want to eliminate my fraction. To do this, I'm going to multiply my entire equation, that's every single term, by the common denominator, which in this case is 6. So when I do that and multiply everything by 6, so 6 times 1/2 is 3. 6 times 1/3, 2. 6 times 5, 6, 5. So I end up with this. And then remember, to solve, you need to set it equal to 0. And now we have a quadratic where we can do product sum. Multiply, remember, so the leading coefficient is not 1. That means I need to multiply 3t squared times 2. That's my product, my sum, negative 5t. So what can I multiply together to get 6t squared? Add together to get negative 5t. That would be negative 3t and negative 2t. I have 4 terms, so I'm going to factor by grouping. I factor out a 3 from the first set of parentheses, a negative 2 from the second set of parentheses. My factors are t minus 1 and 3t minus 2. Set both those equal to 0. T equals 2/3 and t equals 1. I'm sorry, I have x right here, so it's supposed to be a t. In this situation, I'm going to first set this equal to 0. Next, factor out a monomial. So I can factor out a 2x from each one of these terms. So one of my factors is 2x. Now, inside my parentheses, I have a quadratic. I need to use product sum, and I would end up with x minus 7, x plus 3. Set each one of these 3 factors. I don't just have 2 factors in this case, I have 3 factors. I set 2x equal to 0, x minus 7 equal to 0, and x plus 3 equal to 0. When I do that, x equals 0, 7, and negative 3. For my x-intercepts, remember, I must make y 0. And because I have 1, 2, 3, 4 terms, I need to factor by grouping. I can factor an x squared out of the first set of parentheses, and I can factor a negative 4 out of the second set of parentheses. Notice x minus 5, x minus 5. Since they're the same, that's one of my factors. My other factor will be x squared minus 4. But notice, I can still factor this. This is the difference of 2 squares. That equals x minus 2 times x plus 2. So x equals 2, negative 2, and positive 5. But because I want my x-intercepts, I must write them in intercept form, which means I need to write them as points. So the x-intercepts are 2, 0, negative 2, 0, and 5, 0. It is imperative that if it asks for x-intercepts, you must write them as points with the y-coordinate equal to 0. Please make sure you do the My Math Lab out of 6.6. Thank you.